Welcome to the future.
Welcome to the Muxall Open Internet of Things video blog. I am your host, Michael Crane. Well, the Seeed Studio PCBs we ordered in video number 5 have arrived. If you remember, in video number 5, we did a comparison of BAC's standard options with Seed's standard options when ordering our PCBs, trying to figure out why the cost of BAC's PCBs seemed to be an order of magnitude more than Seed's PCBs. There had to be a catch. So, in today's video, we're going to continue our BAC versus Seed comparison, but with the actual PCBs. But before we get started, let's take a look at time. How long did it take for us to get our PCBs from Seed? We ordered our PCBs on August 8th, 2018, and received them August 24th, 2018. It looks like the missing drill files caused a 5-day delay because Seed only processes one PCB at a time, even though both PCBs are in the same order. Check out the first few minutes of video number 6 if you want to see what I'm talking about. Okay, so here's our box of boards we got from Seed, and upon visual inspection, the box looks to be in good shape. I had already opened it just to see if there were boards inside there, and yes, there were. So that's good. The box looks pretty thick. It is not damaged. It looks like the boards were packed well with bubble wrap. And let me get my eyeballs on here. And so there we go. We got, looks like 2 packs of main boards and 1 pack of button boards. There's inside the box. That's not very interesting. All right, so I guess we'll do a quick visual inspection of the packaging. Nothing looks damaged, so that's good. Let's open them up. Oh, they got some silicone gel in there, I guess, to keep the boards dry. That's good. Nice little attention to detail. All right. So, well, the first thing I notice is our logos, our open source logos, are not on the boards. So that's not good. Okay. Let's go ahead and count the boards. Let's see, here's 1, 2, 3, 4, 5. Okay, so 5 in that pack. All right. Let's see, so we should have 30, so there should be 25 in this. Excellent. Okay, so there's all 30 of our boards. And let's go ahead and open our button PCBs. I'm guessing that we probably didn't get our logos on there either. $9 and $30. Yep. All right, very good. Now, let's do a quick visual inspection on it. The open source logo and the Muxall logo did not make it onto the boards. I don't know why. It was in their preview, so I don't know. But on just a quick visual inspection, the boards look to be in pretty good shape. Yeah, let's check the dimensions. I'm showing 90 18. It looked like 18. Actually, it's 18.11. That's close enough. Okay. So, taking a quick look around, all the footprints for all the components seem to be there. That's good. The general appearance of it's good. It's the right color. Excellent. All right. I've got my ruler here. Let's make sure it's the right size. Okay, so we got 115 millimeters in length, and it should be 110 millimeters in width. So it is. Very good. Okay, so let's check the thickness of the board. Let's see, millimeters should be 1.6. Yep, 1.66. That's good. I've got a backboard right here. I want to just check it real quick. It's 1.61. That seems to be a little bit closer. Let's try another part on the board. Maybe I got on top of a big solder pad. 1.68. So that's a little bit thicker. Okay, well, that's no problem for our application. So let's get going and take a look at get a close-up of these boards, all right? To start our evaluation of a Seeed PCB and its comparison with a BAC PCB, let's remind ourselves of what we ordered. Looking at our main PCB order history from Seeed Studio, we pretty much stayed within their standard options, except for our main PCB exceeded Seed's standard 100mm by 100mm PCB dimensions, and we needed to change our minimum solder mask dam to 0.1mm instead of 0.4mm for our DAC. We ordered 30 boards to save money with shipping and to get a coupon for orders over $100. We also ordered 30 button PCBs. We selected all of Seed's standard options with the button boards, and yet Seed charged us $20 for 30 boards instead of the advertised $4.95 for 10 boards, which 3 times $4.95 for 30 boards would equal $15, not $20. But the boards are so cheap, I did not pursue an explanation from Seed. If someone knows, please leave it in the comments. Okay, so let's take a closer look at our main PCB that Seed manufactured for us and see if what we ordered is what we got. The first item on our order, PCB dimensions. Are the PCB dimensions 110 millimeters by 115 millimeters? Yes, they are. And it cost us an extra $30 because those dimensions exceeded Seed's 100 millimeter by 100 millimeter standard option. Item number 2, impedance control. No, we didn't have that. Item number 3, surface finish, Hazel. Did we get hot air solder leveling on our solder pads? Well, I don't see any exposed copper pads, so I say yes. Item 4, minimum solder mask dam, 0.1 millimeters. This is another $30 change fee from Seeed Studios for reducing their standard option of 0.4 millimeters minimum solder mask dam down to 0.1 millimeters because of our DAC. If you remember, in video number 5, we looked at the TI datasheet for our TI Burr Brown DAC and determined that we need a minimum solder mask dam of 0.21 millimeters between the solder mask expansions for the solder pads. Looking at the solder pads for the DAC through a microscope, we can definitely see solder mask between the solder mask expansions. That's good. Item 5. Copper weight, 1 ounce. Did they use 1 ounce copper on our PCBs? I'm going to assume yes. There might be a way to test copper weight in a PCB, like isolating a known length of trace on the board and measuring its resistance, but I'll leave that fun experiment for another video. Item 6. Half cut or castellated holes. None. Item 7. Minimum hole size of 0.3 millimeters. We did not have any holes smaller than 0.3 millimeters. Check. Item 8. PCB color, also known as solder mask. Green. Yep, it's green all right. Item 9. Material. FR4 and TG130. Does our material conform to FR4 and TG130? Well, like copper weight, we really have to trust the manufacturer to test this, since we don't have an easy way to verify conformance. If we start having issues with board warpage or fires while the boards are being reflowed or hand soldered, then we're going to have to investigate further. Item 10. Layers. 2. Yep, we have a top and bottom layer. Item 11. PCB quantity. 30. Did we get 30 boards? Yes, we did. Item 12. Blind vias. Since we only have 2 layers, we don't need any blind or buried vias. So, we're good there. Item 13. PCB thickness. 1.6 millimeters. Check. Item 14. Minimum trace and minimum space. 6/6 mil. We did not have any traces or spaces under 6/1000ths of an inch, so we're good. Item 15. Panelized PCBs. 1. We did not panelize our boards for manufacturing, so technically we only have 1 PCB per panel. Excellent! It looks like Seeed really delivered the goods. Now, let's put the $45 BAC board next to the $9 Seeed board and see how they compare. The BAC board is on the left and the Seeed board is on the right. Please excuse the reflections on the solder pads. All the pads on both boards are perfectly clean and shiny. The solder mask on the Seeed board appears to be slightly darker, thicker, and shinier than BAC solder mask, which is okay. The silkscreen looks good on both boards. I do notice that Seeed has added some sort of manufacturing number to the board, which I don't see on BAC's board. Overlaying the BAC board on top of the Seeed board allows us the opportunity to really see what differences there are between the boards. Varying the transparency on the BAC board from 0% to 100% will help make the differences really jump out. The most obvious difference is that we see the board's name and version number changing locations. I also notice that Terminal Block 2 and Terminal Block 1 reference designators are also changing locations. However, these are expected changes. Since we know the BAC board has been tested and is good, we can use it as a standard to check the Seeed board for mistakes. First, do we have any footprints or reference designators appearing and disappearing? None that I can see. Second, do we have any traces that are appearing, disappearing, or changing in width? Nope. Third, are any solder pads appearing, disappearing, changing in size, or moving location? Nada. Fourth, are any holes changing shape or alignment? Not a one. Well, this is looking really good for the seed board. Let's flip the seed board over and check the back layer with the backboard overlay. Well, except for the slight variations in the solder mask and hazel finish, the back of the seed board looks identical to the back of the backboard. Excellent. Let's pull the microscope out and take an even closer look at the seed and back boards. Starting from the upper left-hand corner of our main board from Seed, we can zoom into J102 and look at some slotted through holes. Increasing the magnification 10 times, we can confirm the slotted through holes are plated. We also see the solder mask alignment is slightly off, but I don't see any breaks in the solder mask between pins, so we're okay. Comparing the same slotted holes on the backboard, we see a noticeably better alignment of the solder mask and in the quality of the hazel finish. But the alignment of the drill holes in the seed board looks as good as BAC's hole alignment. Looking at U1, we see the silk screen on the backboard is not as smooth as on the seed board. But we can also see that the solder mask alignment on the seed board is off here too. Looking at our analog switch, we can see the hazel finish on a couple of the solder pads looks pretty rough. Tilting our view of the board 60 degrees gives us a better view of the unlevel solder pads. Comparing it to BAC solder pads, we see the hazel finish is much smoother on the BAC solder pads. Before we look at the DAC section of our seed board, let's quickly look around at the drill holes, silk screen, solder mask, and hazel finish for our other components and see if anything is different from what we've seen so far. It looks like the seed solder mask alignment gets better towards the bottom of the board. I couldn't find any pads covered with solder mask. The alignment of the seed drill holes look good. I would say as good as BAC's drill hole alignment. The hazel finish on the seed board is still not as smooth as on BAC's finish, but it is acceptable. Surprisingly, Seed's silk screen looks much better than BAC silk screen over the entire board. And Seed was very careful not to cover any solder pads with silk screen. Now, let's take a good look at our DAC solder pads on the Seed board. The DAC has the smallest pin pitch of all our components and will give us the most trouble if the pads are not right. Looking at Seeed solder pads, we still see the solder mask alignment issue, which might be reducing the pad size a bit. But we don't have any missing solder mask between any of the pads, and all the pads look aligned with each other and square. We should have no problems hand soldering a chip in place. Taking a quick look at the button PCB Seeed manufactured for us, we can still see the solder mask alignment issue. Also, the Hazel finish is about the same quality as on our main board. However, the silk screen looks good, and the through holes are plated and have good alignment. Since the button boards are simple, I'm not going to put them under the microscope. I think it's ready for assembly. So what's the error count? Well, the only errors we found with the Seeed boards are missing logos and solder mask alignment. I'll have to do an investigation into the missing Open Hardware and Muxall logos. But my guess is I dorked something up. When I figure it out, I'll let you know. I'm not sure Seed solder mask alignment should count as an error, but it definitely needs improvement. So, what's the verdict? Well, without assembling a board and verifying, 1, the pads don't pull up or get damaged when we hand solder components onto it, 2, the chips align properly with the solder pads, and 3, the assembled board works, I cannot give the Seeed board a thumbs up stamp of approval yet. Do I think we're going to have any of those problems I just listed? No, I don't. So, the verdict is the Seeed PCB is good and ready for assembly. Well, that's about it for this video. I hope you liked it. If you did, please give it a big thumbs up. That always helps. If you have any questions or comments, leave them in the comments under the video, and I'll try to answer them the best I can. And I'll see you later.